So the arrangement of capacitor. Arrangement of capacitor. Mm-mm. So this arrangement of capacitor is tell us the method or way of arrange the capacitor in an electric what circuit. So majorly capacitor can be arranged in what in parallel or in series. At times both. So let us look at the arrangement. So this array is an arrangement. This is arrangement. Okay, you can say what? This is arranged in either series, either what? Series or parallel. Arrange either series or what? Parallel. So let's now take it what? One after the other. You can say what? Capacitors in what? In parallel. Say what? Capacitor in what? Parallel. Let's look at the parallel arrangement of what? Of capacitor. So when two or more capacitors are arranged or connected in parallel, they have the same voltage across them, but different what? Charge. So you cannot say what? When two or more capacitors, when two or more capacitors are arranged or connected in connected in parallel. In what? In parallel, they will have the same potential difference, have the same voltage, which is V, potential difference across them, but different for difference charge. Mm, but difference what? Let's put it that way. Charge what? Q pass through what? Them. You cannot say what? Mm, let's draw this diagram for capacitor. So they are in parallel. Mhm. They will now connect with what? Source, which is what? The battery. This is battery, and this battery have what? Potential difference V. Let me use another marker for that one. So what? The battery has what? V as potential difference. This one is not as also what? This one is not as C1. This is capacitor 2. This is what? Capacitor 3. And when the what? The I'm going to put it like this. Current is flowing in this. The voltage is moving like this. The charge on getting to this place, the charge splits into what? Into three and continue like this. Split into three. The charge, yes, come like this and later come back. We have it in this piece. We observe that this that is moving here is Q, charge, Q. And getting to this point, it's split to how many? To three. The first one is here, Q1, Q2, Q3. But the potential difference that pass through the what? The this one is the same. So they have the same what? Potential difference, but the charge that's stored in each capacitors are what? Are different. So from this diagram, let's say what? So what? Yes. Before we move to the from this diagram, I cannot say since Q equal to the what? CV. Since quantity electric charge is the product of capacitance of a capacitor multiplied by potential difference in the what? In the circuit. So we cannot say what? From the diagram what? Above. Can we use? From the what? From the circuit above. Yes, from this sketch, I can say that the total charge, the what? Total charge Q total. This is the Q what? Total is equal to the sum of charges. Sum of what? Charges. What are the charges? Q1, Q2, and the what? Q3. Let's check it here. This Q total split to the Q1, Q2, Q3. So therefore, the Q total will be equal to what? Q1 plus Q2 plus Q3. So if we agree with what? With this statement, we can call it what? Equation 1. The next thing is, I can also assume that what? Each capacitor has the same potential difference. Abi, you can say what? Each capacitor has the same potential difference, which is V, across them. If this statement is what? Is true. What is what? Our Q is CV. Let us substitute for what? Them. That's what? And and Q is equal to what? CV. So when the Q is equal to CV, we can have what? Here now. Q what? Total. Let me say Q total will change to the what? Q, sorry again. Q total will change to the what? CV. They have the same major difference. T will be equal to what? What is the Q1? C1 V, Q2 C2 V, Q3 C3 V. Why? The Q is what? From here CV. And each capacitor C1, C2, C3, they have the same V. That's why I write V here. But the each charge have the so different C1, C2, C3. I change this Q1 to this, Q2 to this, Q3 to this. But I'm supposed to put V1, V2, V3. But this capacitor C1, C2, they have the same potential difference. So that's why I put what? V or under. The only capacitor and the quantity of charge are what? Are different. So from there now, we can have C total be equal bracket V equal to what? Take the potential difference out, we have C1 plus C2 plus C3. This V cancel this V. Therefore, C total will be equal to the what? C1 plus C2 plus C3. So the effective capacitor of a capacitance in a parallel plate, in a parallel connection of capacitor, it will be what? The sum of each capacitor. So the next thing is what? Let us look at what? The capacitor in what? In series. Capacitor in what? In series. So if you are talking of capacitor in what? In series, it's almost the same with what? This one. Here I said when two or more capacitors are connected in series, they have the same potential what? Difference, but different quality of what? Of charge. Abi? So in the second one, when the what? The two or more capacitors are connected in what? In series, they will have what? The same charge across them, but different what? Voltage. So let us look at what? Capacitor in what? In this. We can now say what? When two or more capacitors are what? Connected. Connect what? Connected in what? In series. Mhm. They have the same, they have the what? The same charge, which is what? Q. They have the same what? Charge, which is what? Q, across them. but different potential different voltage as shown below. So let's check it. A big sketch in this form. If I'm making a big sketch, yes, in this form, it's like I will be what? Satisfied. Let me put my battery here. Yes, negative, positive, good. After that, achieving that. What else again? Let me put my first capacitor here. Put the second capacitor here. Let me put the third capacitor what here. Good. Huh? Yes. So I can now say what? We have C1, C2, C3. So we said they have different what? Voltage. So for this side, this is V1. For this side, this is what? V2. For this side, it will be the what? V3. Good. All together we have VL total. But in terms of what? Of charge. Is the same charge that is what? Pass through the what? The three kappa watts capacitor. So we can now say that what? From this expression, the total potential difference is equal to, let's say what? From the diagram or from the circuit above, like this, you can say what? The, not to say, the total PD potential difference, which is V total potential difference in the circuit, is equal to what? To the sum of the PD, which is V1, V2, and V3 in each capacitors. So by doing that, we can have what? Mathematically, V total equal to the what? V1 plus V2 plus V3. So the second rules, we say that what? Second one, let me put it here. The second rules, we say that what? Each capacitor has the same charge, which is what? Q across them. Charges across what? Across them. If this statement is core from across them, yes, and Q equal to what? CV. If Q equal to what? CV, What else are we doing again now? We can define our V as therefore V equal to what? Q over what? Over C. If we agree that this one is equation 1, so this will be what? Equation what? 2. Substitute for V here. So if we put what? Substitute for V here. At the end of the day, we have what? Q over what? C total equal to the what? Q over what? C1 plus Q over C2 plus Q over what? C3. So if you have it in this case, Q is the same throughout. We have what? Q outside 1 over C total equal to what? Sorry, total equal to the Q outside 1 over C1 plus 1 over C2 plus 1 over what? C3. What will we do next now? Divide this. You have 1 over what? C total will be equal to the what? 1 over C1 plus 1 over C2 plus 1 over what? C3. So this is the what? The general formula for the capacitor when arranged in the what? In the series. So the next thing is what? Let's solve 2 or more questions on these capacitors arrangement both in series and what? Parallel. So let us solve these 2 questions. What in parallel, the other one in what? Series. So the first question, we are given this circuit that comprises of 3 capacitors, 3, 2, and 1 microfarad. From the figure above, calculate the total capacitance in the circuit, potential difference across each capacitor, and the charge in each capacitor. Solution. So to solve this kind of question, question number 1, we can say what? We are given C1 to be 3 microfarad, C2 is to be 2 microfarad, C3 is what? 1 microfarad. We are now asked to find the total capacitance. That is, our C total is what? Unknown. But don't forget that this circuit is in what? In parallel. You can now say what? Since circuit is in what? Parallel connection. The C total will be equal to the what? C1 plus C2 plus what? C3. Therefore, the total capacitance in the circuit will be what? 3 microfarad plus 2 microfarad plus 1 microfarad. Therefore, the C total will be what? 6 microfarad. Because it's in what? In parallel. The question number 2, we are asked to find the potential difference across each capacitors. So the potential difference across each what? Capacitor. Abi, the same thing. You can also say what? Since the what? Since the capacitors are parallel. Since capacitors are what? Parallel. They have same potential difference across their terminal. Yes. So you can now say what? That is V equal to the what? V1, the V2 equal to the what? V3. As we have done that before, when they are in parallel, they have the same potential what? Difference across what? Across them. And the potential difference given there is what? Is 200 volts. So 200 volts. There's no need to what? To disturb ourselves again. So whenever the capacitors are arranged in what? In parallel, the same voltage pass through what? Pass through them. So let us now move to the question number 3. Calculate the charge stored in each capacitor. So let us look at the charge stored in each capacitor. You can say what? Charge stored by 3 microfarad. Stored by 3 what? Microfarad. And we know that what? Q is equal to the what? CV. So this is the C, this is the what? Phi. So the charge stored by 3 microfarad will be what? What is the C? We have 3 microfarad multiplied by what? 3 micro. This micro is what? Times 10 raised to power minus 6 multiplied by what? 200. The charge in each capacitor, the first one is 3 this. So if you multiply what? 3 times this one times 2, we have 600 times 10 raised to power what? Minus 4 coulomb. That's for this. The second one is charge stored by, what is the second one? 2 coulomb. 2 microcoulomb, microfarad. We know that what? Q equal to the what? CV. Can have what? C. Q equal to the what? What is the first one? We have C. C is what? Is 2 multiplied by 10. This micro 6 multiplied by what? 2 what? 200. That it should be give us what? 4 times 10 raised to power minus 4 again. So the next one is what? Charge stored by 1 microfarad. Q is CV. When Q is what? Is CV. The next thing that we do is what? We can agree that is CV. What do we have? 1 2 is this. So yeah, this is question 1 what? 1 3. And this is 1 3. Yes. Microcoulomb. We have Q to be equal. What is 1 multiplied by 10 raised to power minus 6 multiplied by what? 200. So at the end of the day, we have 1 times this. It will give us 2 multiplied by 10 raised to power what? Minus 4. That is what? The potential difference across, the charge stored in each what? Capacitor. But at times, they can also add this question. Let me add this to it. That Let me add this one. If you're asked to find the what? Total charge. Total what? Charge stored in the circuits or in the capacitor. In kappa what? Capacitor, in the plate. The total charge will be what? QT will be Q1 plus Q2, Q3. So the total charge will be charge of the first one, you get, which is on the what? First capacitor, which is 6 times 10 raised to the power minus 4, plus charge of this one, 4 times 10 raised to the power minus 4, plus charge of this one, 2 times 10 raised to the power minus 4. So if you add everything together, 10, 12, the total charge will give us what? 1.2 times 10 raised to the power minus 3 coulomb. So that is what? The solution for what? For this first question. So I'm the one that is add this one to it. At times, I calculate the total charge present in the what? Circuit. So the second question, our capacitors is in what? In series. You are asked to find the total capacitance in the circuit, the charge in the circuit, energy stored by each capacitor, potential difference across each capacitor. Let us take it one after the what? Other solution. The first question we have to what? We are asked to what? Total capacitance is the what? In the circuit. You know, is in a series. Abi? You can say what? What is in the series? The total capacitor is 1 over C. So the what? C1 plus what? 1 over C2. 1 over what? C3. Good. What is our first capacitor? This is C1. This is C2. This is C3. So help me to what? To put it here. By substituting here, we have what? C1 is what? 1 over what? 1 microfarad plus, here we have 8. 1 plus 8 microfarad plus, what is the third one? 4 plus 1 over 4 microfarad. If we do the arithmetic, we have 1 over C1 total. Everything will be 11 over what? Over 8 by doing the arithmetics. But if you press calculator for 11 over 8, so from this now, if you, to give you what? 8 over what? 11 by, we are make this formula, the final answer here, it will be 0.73 microfarad. That is what? The total capacitance in the circuit in this series. The next one, the charge in each circuit. So the charge in each circuit will be what? If you know that what? It's in the series. So the same charge is passed through the what? The circuit. So the charge in the circuit, Abi, then charge stored by each capacitor. Good. You can now say what? Roman figure 2. The what? The charge in the what? In the circuit. What? Using Q equal to the what? CV to know the what? The total charge in the circuit. So once you know the total what here, what is our what? Potential difference. We have 20 what? 24. You can now substitute. The Q is this one we get here is 0.743 microwatt farad multiplied by what? The V, which is potential difference we have here, 24. You now have what? 24 for V. By pressing the calculator, our final answer will be what? That will be 1.170.5 microcoulomb per charge. That is what? The final answer for the charge. the Roman figure 3, we are asked calculate the what? The charge stored by each capacitor. Note that what is in a series, the same charge passes through the Q1, Q2, Q3 is capacitor 1, capacitor 2, capacitor 3. But the potential difference are what are different. So what would I do now? Yes, do here is since you cannot say what since the capacitance are connected in series, are connected in what? Series. Then the same charge flow through them. Then the same charge Q flow through what? Through them. Good. If it that be case, we have Q should be equal to what? Q total equal to the Q1, Q2, Q3. As a result of that, what is the Q total we have? Is 17 point this. We now have what? 17.5 microcoulomb is flow through what? 1 microfarad, 8 microfarad, and a 3 microwatt farad. The question number what? Number 4. Potential difference across each. That one is easy. You cannot say what? Equation what? Equation 4. The potential difference across each will migrate to what? By using V equal to the what? Q over what? Over C. So the potential difference for what is the first charge we have? 1 microcoulomb. So its potential difference will be V equal to the what? Q. What is the charge? Charge is 17.5 over what? Over C, which is what? 1 multiplied by 10 raised to the power minus 6. That is what? The potential difference in what? In this one. So you put your final answer here. 4, or what is the second one? 8 microfarad. So our V will be equal to the what? 17 point what? 5 over what? 8 multiplied by 10 minus 6. Then for what? The last one, 4 microfarad, we have what? V should be equal to 17.5 over what? 4 times 10 raised to the power minus 6. So by pressing the calculator, you have your final answer here. So that is all about what? These two questions. And I will still add to what? To add more questions on it. But these questions, they are what? The theoretical parts of capacitors. Let me try to add what? The multiple choice question for capacitors. So before we now move to the energy stored in capacitor and energy density, then the force of attraction that exists in parallel plate capacitor. After the force of the parallel plate capacitor, they are good to go for the condenser, which is what? Capacitor. 3 short answer question or multiple choice questions. The solution. We are given a 300 nanometer or 300 nanofarad capacitor is connected a 250 battery. Calculate the charge on capacitors placed. So the third one, we have to calculate the charge. We are given C should be what? 300 nanofarads, which is everything as what? 300 multiplied by 10 raised to the power what? 9 farad. So nanofarad derived from microfarad, and potential difference is 250. Then the what again? The charge Q is what? Unknown. You can now say what? Using Q is equal to CV. By applying Q equal to the CV, what is the C? 300 times 10 raised to the power minus 9 multiplied by 250 volts. So by multiply this, Q will give me what? 7.5 times 10 raised to the power minus 5 coulomb. That is the answer for question number what? 3. The next thing is question number 2. Calculate the capacitor as a charge of 6 times 10 raised to the power minus 3. So question number what? 4. We are given that charge Q is equal to what? 6 multiplied by 10 raised to the power minus 3 coulomb, when potential difference across the place is what? The V across the place is 200 volts. Calculate the what? Its capacitor. So you will use the same formula. We say that Q equal to the what? CV. From this expression, we can still have our what? Our C should be Q over what? Over V. So from this expression, this Q, what is the Q given? Our Q given is 6 times 10 raised to the power minus 3 coulomb. Everything over what? 200. So if we press our calculator, the final answer will be 30 microfarads. It will be 30 what? Microfarads. That's the answer for what? For that. If you look at this, question number 3, number 5. This one is absolutely different from everything we are doing since morning. 5. 3 capacitor Ds 2, 3, 4 are connected in parallel. What is their equivalent capacitance, and what is the charge on each capacitance? This 1, 2, 3 are connected in parallel. You can solve it without drawing the diagram, but let me draw the diagram. Connected in parallel. What is the first charge? The first charge is 2 microfarad. The second one, we are given 3 microfarad. The third one, we are given 4 microfarad. So, connected parallel, what is the equivalent? What is the equivalent to this 500 volts? So, the volts that we have in the battery end is what? We said the volt is 2 or 500 volts. We have 500 volts. So from this sketch now, we are asked to find the what? To determine what is their equivalent capacitance. So whenever this thing is in what? Is in series, Abi, you can say what? Since capacitor are in what? In parallel. So when they are in parallel, we have C total equal to what? C1 plus C2 plus C3. So the C total will be equal to the what? We have 2 plus, we have 2 microfarad plus 3 microfarad plus 4 microfarad. Abi now? So all together, you can add everything together. The C total will give me what? That will be 9 microfarad. That will be total capacitors in the what? In the circuit. The second question, we are asked to find the what? The charge on each what? On each capacitor. So the charge on each capacitor is for capacitors 1 for 2 microfarad. You can have what? Q1 equal to the what? C1V. What is C1? 2 times 10 raised to power minus 6 multiplied by what? What is V? 5 watts. 500 volts. 2 multiplied by 500 volts is giving you what? 100 volts. This is 10 raised to power what? Minus what? 6. So if I multiply it, at the end of the day, I will have what? 1 multiplied by 10 raised to power minus 3 coulomb. Therefore, the charge on Q1 is what? Times 10 raised to power minus 3 coulomb. The second one for 3 microfarad, you can then say what? Q1 is Q2 equal to the what? C2 V. What is C2? Is 3 multiplied by 10 raised to power minus 6 multiplied by what? 500 to give us what? 3 times this, that will be 15. That will be 5.10 raised to power minus 3 coulomb. Therefore, the Q2 will be equal to the what? 1.5 times 10 raised to power minus 3 coulomb. So for 4 microfarad, we have what? Q3, the what? C3V. C3V is 4 multiplied by 10 raised to power minus 6 multiplied by what? 500 what? Volts. At the end of the day, we have what? 4 times 5. That will be 20. Yes, we have 2 times what? Times 10 raised to power minus 3 coulomb. So the Q3 is equal to what? 2 times 10 raised to power minus 3 coulomb. So that is all about what? The 3 questions. So the next aspect now, I'm trying to move to the energy stored in capacitor.